This lecture is just going to be a little wrap-up of resistors and capacitors when you have them together, RC circuits, not remote controlled, but resistor-capacitor circuits. You can follow along if you have your book. So basically, in an RC circuit, you have a resistor and a capacitor together. Now, when the circuit, the current is flowing, the resistor is going to dominate what's happening, and then over time, the charge from that current is going to build up on the capacitor, and then the capacitor is going to accumulate all of the potential under the stored energy, the voltage. So you're not going to be able to have anything moving. So over time, the current's going to die off and the charge on the capacitor is going to grow. Now if you start out with a charged capacitor, it starts out with some charge Q. You can use that as, you solve that as V over V times delta C, or delta V times C, and solve for that. And it drops off like 1 minus this decaying exponential. So that's E, that's Euler's number, the 2.7 blah blah blah, and minus T over tau. So it's dropping off, it's decaying in time. And that time constant, sometimes called T0 depending on what book or units you use for it, is equal to the resistance multiplied by the capacitance. If you go into what an ohm is and what a farad is and you multiply them together, you'll get seconds. So a charging capacitor, it kind of goes from 0 up to some maximum value, and a discharging capacitor, it goes the other way, and the voltage is just going to be the same basic shape. So here's a charging capacitor over 5 time constants, it goes to there. So after one constant, time constant, it increases like e to the minus 1. All right, and the same thing for discharging. So after 5 times constants, it's pretty close to 0. All right, that should prepare you for lab. All right, thanks a lot.